So today we will discuss about how to estimate mean precipitation with the help of Isohyetal method. As already discussed, there are three most common methods for estimating mean precipitation of a watershed from the different rainfall as measured by the different gauge stations available in that watershed. So is uh, this is what we know as Isohyetal method. Now, before beginning, let us explain what is isohyetal lines. So the isohyetal lines is that line which connects the points which have equal precipitation. Suppose in a watershed there are different gauge stations, correct? Now, if I filter out those gauge stations which has measured today's rainfall as 5 millimeter, then we can draw a curved line within the watershed like this. So in this line, the precipitation as measured by the gauge points or gauge station is same. That means 5 millimeter. Similarly, there can be another line which connects those points which have a precipitation of 4 millimeter, and so like this. So generally what happens if this is the watershed, then the isohyetal lines are like this generally, and this line represents one precipitation, this line represents another precipitation, this is another, this is another. You can note that this P1 and P2 is bordering interhyetal area. The area bordered by interhyetal lines is known as interhyetal area. So this is that area. This area is bordered by the line which represents the precipitation P1 and P2. Similarly, for P2 and P3 is engulfing this area or bordering this area, and then P3 and P4 bordering this area, and so on. And here also you have to begin from 0 to 1 to 2 to 3 to 4 to n. Correct? So to find the mean precipitation of this entire watershed, you have to apply this formula. A1, this is the interhyetal area between P1 and P2, multiplied by P1 plus P2 divided by 2. So this, if this is area 1 as bordered by P1 and P2, then this will be A1 multiplied by P1 by P2 divided by 2. Okay, plus A3 multiplied by P2 plus P3. That means A3, if this is the area A3, and this is the P2 and P3, then this will be A3 multiplied by P2 plus P3 divided by 2, and so on, and an minus 1 into Pn minus 1 plus Pn. So as you can see that if this is P1 and P2 and this is A1, then you multiply A1 into P1 plus P2 by 2. This is 1. Plus, then you go to the next one, P2 and P3, and this will be your A3. So this A3 multiplied by P2 plus P3. You note that whatever number of gauge station or whatever number of precipitation, this area is before that precipitation. That means, let us be very clear, P1 and P2 both borders this area A1. Okay, but P2 and P3, it is bordered by the area A3. So I think here there is a mistake. This is not bordered by A3, but it is bordered by A2. And P3 for P4, A3. P4 and Pn, this area will be An minus 1. So whatever subscript is there, this area will be minus 1. Correct? So if this is 0 and 1, this area will be 0. Again I am saying P1, P2, this is P2 minus 1, A1. So area bordered by P1 and P2 will be named as A1. Area bordered by P2 and P3 will be named as A2. Area bordered by P3 and P4 will be A3. Area bordered by P4 and Pn, suppose this is Pn, will be An minus 1. Correct? And area bordered by 0 to P1 will be A0 because P1 minus 1 is 0. So A0. That is why what happened is, in here, if this is Pn, this will be Pan minus 1. And this will be Pn minus 1, certainly, because if this is 3, this will be 2, because this P2 and P3 is bordering the A2. Okay. So in this way, we will name the precipitation as well as the area bordered by them. The formula is like this. I have already discussed, and this will also be 2. And this will be your PM, mean precipitation. So let us take some numerical example of estimating mean precipitation of a watershed with the help of isohyetal lines. So this is the estimate PM if the area and precipitation of the isohyetal lines is as given below. So here you see P0 is given, P1 is given, P2 is given, P3 is given, P4 is given, P5 is given, P6 is given. Correct? And also P7 is given. And this area is also given, that is the area which is bordered by P0 and P1 is A0, then A1 bordered by P1 and P2, then A2 bordered by P2 and P3, and so on, as we have already explained. So P0, P1 is bordering A0, P1 and P2 is bordering A1, P2 and P3 is bordering A2, P3 and P4 is bordering A3, P4 and P5 is bordering A4, P5 and P6 is bordering A5, and P6 and P7 is bordering A6, and so on. So we'll calculate up to A5, that means the area which has been bordered by P4 and P5 and P6, up to this we'll calculate. So the values are given, the precipitation and area values. As you know, the formula is also given, A0 into P0 plus P1 by 2, then plus A1 into P1 plus P2 by 2, like this. So what happens is, you just put values. What is the value of A0? 0 square meter. We have taken area square meter, precipitation in millimeter. So A0 is 0. So this entire term gets 0 because anything multiplied by 0 is 0. So let us come into the next part. A1 multiplied by P1 plus P2 by 2. A1 multiplied by P1 plus P2 by 2. As you see, if this is P2, this will be A1 because P1 and P2 is engulfing A1. Similarly, if this is P3, this will be A2 because P2 and P3 is engulfing or bordering A2. So the value of A1 is given. A1 is 2, so this will be 2. And P1 is 5, so 5, P1 is 5, P2 is 7, that's 7, so 5 plus 7 by 2, that is 12, 5 plus 7 is 12, divided by 2 will be 6. Now this is 6 millimeter, this is square meter, right? So you will keep it as this sort, 2 into 6, plus, you know what is area 1, area 1 is given, it is 2, area 1 is given, so it is 2. Sorry, we have already calculated area 1, so we are going to A2. So A2 is given, it is 3, and this area A2 is bordered by P2 and P3. So P2 is 7, P3 is 8, 7 plus 8, 15 by 2 is 7.5. Then come to the next one, that means this A3, correct? A3 is given as, where is A3? 5, so 5. And A3 is being bordered by P3 and P4. P3 is 8 millimeter, P4 is 12 millimeter. 8 plus 12 is 20, divided by 2 is 10. Keep it like this. Next, come to the next one. That means A4. A4 is bordered by P4 and P5. P4 is 12, P5 is 18. 12 and 18, 30. 12, 18, 12 plus 18, 30. 30 divided by